wardens, members of the livery, distinguished guests and speakers, delegates, ladies and gentlemen, a very warm welcome, quite literally given today's temperatures, to this, the 41st Worshipful Company of Plumbers annual lecture. For the first time, it's being held to coincide with the prestigious World Plumbing Conference. As Master, I'm honoured we continue these lectures, inaugurated by my old friend, late past Master Jeff Marsh, who played such a key role in founding the World Plumbing Council. I'm delighted to see some plumbing student award winners here today. I look forward to recognising their success later. Also present are 4 plumbers at the start of their careers who are members of our Plumbing Professional Development Scheme. Tomorrow at 9:30, they will provide a presentation about their experience helping to deliver a water distribution project in Nepal. It would be wonderful if you can try to attend their lively presentation and learn more about PPDS. For those of you not familiar with the Plumbers Company, we are an ancient London livery company. We were originally formed in 1365 to regulate the plumbing trade in London. Our primary purpose was to protect public health by setting strict standards for leadwork, sanitation and water supply. This was achieved through preventing poor workmanship and managing the training of apprentices. To see some of the history, why not visit our museum at Amberley in West Sussex, where you can see lead being cast. Today, while plumbing technology has evolved, the company upholds that legacy. As you will hear later, we provide bursaries and educational support for plumbing trainees. We focus a lot on charitable work, supporting particularly water-related projects in the UK and overseas. We are a membership organisation, and at our heart is social networking. We have the reputation of being the friendliest livery company in London. Please visit our stand in Hall 4, so that's 4J39, to discuss how to join as an individual, bursaries, or how to become a sponsor. Our friendly team on the stand will be glad to help. I thank them for their hard work this week. Tonight's topic was chosen to appeal to an international audience. I wanted a subject that affects every one of us and which will do for many years to come. Hence the subject of water security. I needed someone who could speak positively and point us towards potential solutions. I was thrilled when Matthew Griffin accepted my invitation. I shall ask Julie to formally introduce Matthew, but just to say for my part, if we can get you to leave this room feeling positive, with a can-do attitude and belief that with ingenuity and will, we can resolve the water crisis we hear about every day, then we'll have succeeded in our task tonight.
Just that one by that gentleman.
We here today are the water industry. The solutions lie in our hands. Before I pass over to Julie Spinks, the chair of our Education Technical Committee, who will be facilitating our lecture, a few special thanks from me. To Kevin Wellman, CEO, and President Jason Clark, and our many, many dear friends at the CIPHE for their help in putting this lecture on. To the World Plumbing Council for their collaboration over many, many years. The Installer Show and the 19 Group, who have welcomed us to be part of this prestigious conference. And finally, our sponsors, BHWM, PEW, Catch Pole and Rye, and HDR. We obviously would be the poorer without you. It now gives me great pleasure to hand over to Julie Spinks.
Thank you, Sandra. So hello again. It feels 5 minutes since we met last time. So thank you very much for that warm welcome. Indeed, I'm delighted to welcome you to this, the Worshipful Plumbers Annual Lecture 2026 for the first time within this prestigious conference. So our lecture today is about the future of water security. And my goodness, we've actually been talking about this quite a lot over the last couple of days. So it's a really important topic in the spotlight. So it's my job to introduce the speaker who's going to help us decode future trends and consider what it means for the plumbing industry. I'm really delighted to have Matthew Griffin with us. A little bit about Matthew before he comes on stage. So Matthew is a multi-award winning futurist. I wish I had that as a job title. It makes me sound really dull in comparison, in terms of what I do. But he's a leading expert on innovation, disruption, and emerging technologies, described by NASA. I mean, fancy having NASA describe you anyway. A walking encyclopedia of the future. He's a founder and futurist-in-chief of the 311 Institute, advising global leaders, governments, major organisations, and indeed helping them shape their organisations over 50 years. So we've been talking about those horizons already today. He's a best-selling author and sought-after keynote speaker, and he works with lots of institutions, including the United Nations, the World Economic Forum, and helping organisations build a fair and sustainable future. Probably what I like, too, is he's grounded that he did business, too. So he's worked in organisations at the coalface and been a senior executive at a number of prestigious organisations. So he's got real world experience that he's bringing to us as well. So Matthew's mission is to help organisations create a fair and sustainable future whose benefits are shared by everyone, irrespective of their ability and background and circumstance, which links us quite nicely into tomorrow's themes as well. So without any further ado, I'd like to welcome with me Matthew Griffin to the stage.
Yeah.
Thank you.
Thank you. Thank you, Julie. Thank you, Sandra. So how are you all?
Fine.
Good, feeling good. So all fed and watered. Excellent. So I've been a water enthusiast and addicted to water really for many, many years now. So it's really nice to sort of be representing the industry here today. Now, as Julie said, my name is Matthew Griffin. I'm the CEO and founder of the 311 Institute. We're a global futures and deep futures organisation working up to 50 years out. I work with royal households, I work with 70 governments around the world, I work with the United Nations, basically where we look at how we actually try to solve all of the United Nations SDGs. And as we say at COP28, COP29, COP30, when it comes to the world's problems, we have the solutions that we need. The question then becomes, do we actually have the investment and the willpower to actually scale those up and out? So in this particular presentation, what I'm going to do is I'm going to take you through the future of water scarcity, which is kind of ironic because water isn't scarce. Now, when we think about water, all of you are taking part in an industry that is actually providing everything that we all need. In 2010, the United Nations deemed access to fresh water as a fundamental human right. So when we think about installers, when we think about plumbers, when you're actually helping connect people's homes basically to the water mains and the piping and the systems and everything else, you're helping enforce a fundamental human right, which, that's a big deal. It goes alongside Wi-Fi, that a lot of teenagers think should be a human right. Now, from a planetary perspective, we're called Earth. However, if you were an extraterrestrial and you came to this planet and you landed on the Pacific side, it would be called water. 97.5% of the world basically is seawater and saline. 2.5% is fresh water, and only half of that is actually accessible. Now, when we talk about accessible, this is where we talk about water that is not locked in ice. It's near the surface. But typically when we talk about accessible in liquid form, we also don't talk about water from Earth's atmosphere. So with companies like General Electric, we've been developing 3D printed heat exchangers, which you can take to the middle of Namibia and extract 500 litres of water basically from desert air. And globally, should there be any doubt about water scarcity, there are 366 billion trillion litres of water on our watery planet. So from a societal perspective, that sounds great. But this is the challenge. Today, agriculture uses 70% of potable and fresh water. Industry, like the artificial intelligence industry, steel and aluminium industries, use another 22%. And as humans, we have access to 8%. Now, 8% of the available water that we actually have, that's still a lot of water, but we face fundamental challenges here. Because what we ultimately have is we have lots of water, but we've got the wrong kind of water in the wrong place. We don't have a water scarcity problem, we have a water distribution problem. And that's where you come in and that's where you help. Today, basically, we have over 8 billion people on our planet. So when we think about how we're trying to use the fresh water that we do actually have access to as the weather around us changes, we have more mouths and more people on the planet than ever before. Now, from an agricultural perspective, if you want to feed 8 billion people, which we do, you need 10 billion tons of crops. All these crops need water. They need fresh water. We have to raise 85 billion livestock. They need water. They need fresh water. Every year we're consuming 124 billion fish. This is what it takes to feed a planet. And so from an agricultural perspective, we kind of have problems. If you go to California, in California they grow almonds, but 90% of California over the past couple of years has been under drought conditions. So the almond farmers have been cutting their trees down. We see this across Europe. Last year we lost 40% of Europe's crops to high heat and high stress. So every year, out of this 10 billion tons of food, shall we say, that we grow, we're losing 40% to disease and pests. As we see temperatures rise, as we see the Earth's atmosphere become more moist and more wet, we see more pests. And we see more disease, like rot and mold and everything else, basically, in our crops. And we try to use synthetic biology and genetic engineering to engineer new kinds of crops. But 8% of the world's crops are wiped out by bad weather. So if you watch Clarkson's farm, basically you'll know that one day basically his crops basically are being flooded and the next day they are under drought conditions. We grow 10 billion tons of crops, but 50% of that never ever reaches your plate. And out of that 50% that remains, 30% of that goes into landfill because we have high amounts of food waste. From an ocean perspective, the ticking time bomb from a climate perspective is not Earth's atmosphere, it's the oceans. We are loading 1 atomic bomb's worth of heat into the Earth's oceans every second. So over the past 20 years, we've seen oceanic surface temperatures increase by half a degree C. Now that doesn't really sound very much. You wouldn't even notice that if it was your bath. But from an ocean perspective, that has increased oceanic pH by 30%. It's impacted 66% of species in the Earth's ocean, especially those basically with calcified skeletons like starfish, echinoderms, bony fish. And it's actually reduced fisheries yields by 3%. This is all against basically an increasingly sort of runaway climate sort of agenda. But we also need more people. We've got more people coming onto the planet. And so these are trends basically that we need to try to reverse. When we think about the Earth's rivers, 66% of Earth's rivers do not get enough water. 2/3 of the Earth's rivers are now imbalanced. 80% of all urban planetary discharge, so wastewater from industrial plants, homes, goes straight into our rivers. We see that in the UK with a lot of the pollution statistics. And 90% of the Earth's rivers have high levels of microplastics, according to the UNEP. So, on the one hand, access to fresh water is difficult enough. But then access to clean, fresh water, that's actually getting harder. So we have multiple problems as an industry that we need to try to solve. Now, from a climate change perspective, we're frankly in the position now where we have wetter wets and drier dries. This is why California can bake in the sun and Germany can drown in the floods. So we're now having many more weather extremes, which then means that the imbalance of having the right water in the right place at the right time is harder to manage. In China, they've been building waterways to connect the northwest of China with Beijing, because increasingly China basically sees that water is going to be the thing that determines, to a large degree, their economic future. And this is the ridiculous piece. None of you would be alive without water. Period. At all. From a consumer perspective, all of us treat water as a commodity. If you have a look at your energy bills for gas and electricity, most of you will complain about your energy bills. How many of you have ever complained about your water bill? Yeah, there you go. Yeah, 30 quid a month. There you go, yeah. That's it, exactly. It's like flipping go. Water rates going up by 8%, Severn Trent Water again. But the fact is, we treat it as a commodity, especially in the West. Now, I travel around the world. I've been in 100 countries over the past couple of years. I was in Cape Town a long time ago, basically where Cape Town was on the very verge of running out of water. They were rationing water and giving people about 50 litres of water a day. And I remember basically if you actually went into the washrooms at Cape Town Airport and you washed your hands, you'd almost end up in a fight. Because people would go, don't you realise there is a water shortage basically in Cape Town? How dare you wash your hands after going to the loo? So I didn't shake any hands after that. But the fact of the matter is, when you have a look at India, basically, we're using more potable water. There's a huge black market, basically, for water in India now, especially in Delhi, basically, and other places. So as consumers, we treat water as a commodity. And in the UK, we use about 135 to 140 litres per person. And we are a little bit frugal with our water, but we kind of take water running out of our taps for granted. If our water isn't running out of our taps, then we call a plumber, because we've got a leak somewhere. But I also work with the world's largest investment firms. We have $60 trillion worth of investments. Around $34 trillion of those investments are in ESG. Citi alone have a $1 trillion ESG investment fund. And do you know who doesn't increasingly treat water as a commodity, or at least not in the same way that we consumers do? Wall Street. When you have a look at hedge funds, when you have a look at water leases, when you have a look at water contracts, increasingly, Wall Street is trading water and water futures as an asset. Because they know, basically, that as water becomes increasingly imbalanced around the planet, scarce in some areas, they all know that you're going to need it. This is especially prevalent in the United States, where we see water contracts, for example, up the Colorado River, and we see people fighting over them and bidding. So by 2033, we estimate that water futures basically will be a $54 billion business. At the moment, to put it into perspective, it's running at about $34 billion. So as we see more water scarcity, as we see a growing population, as we see more challenges around agriculture, people are going to be buying your water for you. And then your bills will increase. However, we have solutions. We have solutions for everything. So, for example, if we want to actually reduce agriculture's impact on the planet, just from a water perspective, in London and Birmingham and Manchester, we have vertical farms. Vertical farms basically are farms in buildings like this that operate closed loop systems. So in a vertical farm, we use 99% less potable water. We can either extract water from the air and the atmosphere, or we just recycle water efficiently basically within the vertical farm itself. We're scaling these throughout China, throughout the Middle East, and increasingly we're scaling these basically on the west coast of the United States. But they're expensive. In addition to that, when we think about the amount of water that cows and livestock need, we have 85 billion livestock today. That's a number that will soon be 100 billion livestock. We can take a single cell from any animal on earth, a cow, a chicken, a duck, a zebra, a Tyrannosaurus rex, a tiger, and we can put that single cell into what we call a bioreactor, and we can grow fresh meat from that single cell. We do outside of a chicken what normally happens inside of a chicken. So we can feed the planet today, and we've proven it, with an infinite amount of chicken without ever having to kill a single chicken. This trend is called cellular agriculture. And if you want to buy meat basically made in this way, go to Walmart in the United States. Go to Singapore and other places. Now, when we think about the wrong kind of water being in the wrong kind of place, in the Middle East, the vast majority of consumer water and industry water is actually desalinated. Similar basically in Spain. So I do a lot of work with the Spanish government. The Spanish government believe that the lower third of Spain, roughly by 2050, will be arid. If you've been to Barcelona over the past couple of years, you'll notice that there's been water rationing going on in southeast Spain. So increasingly we see more desalination plants being built. But desalinated water is normally 3 times more expensive per litre than potable water. So guess what? We solved that. So we use renewable energy to boil water, to split it out, so we've got pure water. Then we're left with brine. Now brine basically is very dangerous. You exfiltrate it into the sea, it'll kill anything it touches. So we process that brine and we can extract uranium and lithium from that brine. And then we sell the lithium for $3,000 a kilo, basically to Volkswagen and anyone else basically that wants lithium in today's energy transition world. And now what we have is we have desalinated water that is the same cost as potable water, or that we could even give away for free, with zero energy footprint. These are the plants that we're building in Saudi Arabia now, and the companies that are building these plants in Saudi Arabia, they're British. Now that leaves us basically with the next scourge, AI data centers. Yes. Ooh. Now, AI data centers consume huge amounts of electricity. When we think about some of the larger AI data centers today, like the ones in Utah, we have 10 gigawatt data centers being built. Now, to put it into perspective, an AI data center that draws 10 gigawatts of electricity needs the equivalent of 10 nuclear power stations to power it. Wow. But from a water perspective, these data centers are increasingly in water-stressed areas. Now, with Google and Google's new Texas AI data center, which is a big hyperscale data center, it doesn't use water. It's a closed loop system. However, if you actually go and have a conversation with Google and you say, right, you're building a new hyperscale AI factory in Austin, in Texas, and we've heard it doesn't use water, then the head of sustainability for Google, she'll say, no, it doesn't use water, no. And then she'll correct herself, and you go, oh, here you go. She goes, actually, it does use water. And you're like, here you go. Here's the drop. It's a load of marketing hype. And she goes, yeah, it does actually use water. It uses water for the canteen. We have solutions to every problem that you can throw at us, pretty much. Now in the UK, the plumbing industry, so this is specifically water only, so the electricians can go and do their own thing. In the UK, trade supply, basically for the plumbing industry, basically is worth £3 billion. And the industry itself is worth £9 billion, and this is sort of last year. We've got 133,000 people that are employed in this sector. Now, from an employment perspective, are we a market leader? Are we in the UK building, designing new water, shall we say, infrastructure and systems that we can export to the rest of the world? Having worked in 100 countries, I don't think we are. We've got a huge opportunity here to actually export our world expertise and our technology expertise to the rest of the world in a way that no other country actually could. And over the next sort of 6 years, as a country, we're investing $100 billion basically in new water infrastructure. But by 2030, we will have a shortfall of 50,000 people. Now, this isn't actually that bad. If you look at the telecom sector globally, basically we've got a shortfall of about 1.5 million people. So we have a shortfall in the workforce that we actually need up to 2030 for both civil and consumer, so water-based things. But I think we can actually make that up, especially if government sorts out their regulations and everything else. Yes. We've got 352,000 kilometers of clean water mains. And most of these are being upgraded, but a lot of them are very old, as we know. But every year, actually every day rather, we are losing 3 billion, with a B, litres of treated water into the ground around us. So when we think about water scarcity and everything else, are there some things that we can actually do? From a UK perspective, we are extracting less water from our aquifers today than we did 20 years ago. From a leaks perspective, we are losing less water today through leaks and leakage than we did 20 years ago. How many of you heard about that in the press? Or do you just continue to hear about the water utilities problems and how much they all suck? Don't listen to the news. Turn that crap off. Yeah. Now, even though plumbing basically is a centuries old, even millennia old, if we go back to Roman times, basically with aquifers in Rome, even though plumbing basically is a millennia old industry and trade, it's meeting high tech. So as a futurist, I look up to 50 years out. I track over 600 emerging technologies, and we're doing some interesting things. Now, firstly, from an industry perspective, how are you prepared for the arrival of fully autonomous cyber weapons systems? I can use an artificial intelligence today to make 10,000 new malware variants in 5 minutes. I can create new CVE zero-day exploits in 5 minutes. Chaining together AI agents we have already been able to slice through military-grade security systems in 2 minutes. So, if any of you think basically that Britain's critical national infrastructure is safe, that we are done, we can pack up for the day, we haven't got started yet. And as the UK, we are world leaders increasingly in cyber. Now, when we think about nanotechnology, increasingly, basically, we're using nanotechnology like graphene and nanofiber composites to create what we call single-step filtration systems. Now, on the one hand, these single-step filtration systems increasingly filter out viruses, microplastics, and all these kinds of things. So we have ways to clean up the rivers and the water, basically, that we are pushing into treatment centres. In the UK, specifically, we are almost the world leader in developing robotics that go and monitor, assess, and diagnose problems with infrastructure. Whether that be Rolls-Royce jet engines, or whether it be the pipes beneath our feet. And then when we think about trying to identify wastewater leakage and everything else, we're using sound. So we can use hyperspectral sensing, we can use quantum sensing and all sorts. You can put a hyperspectral sensor onto a drone and you can identify where the underground leaks are. And you can do that autonomously while you're actually having a cup of tea. But with companies like Suez, we're using sound. So we can hear where the leaks are. Now, when we think about the home, increasingly, we can use artificial intelligence, bearing in mind that ChatGPT that you use today has an IQ of 155. It has 4,000 times more general knowledge than any human, which is why you can ask it, how would I rig a boiler? How would I bake a cake? How do I do a project management task? So today you have access to super intelligent artificial intelligence. Gemini 3.5, Grok 4, they are all post-PhD level AIs. So on the one hand, basically we can use bots and artificial intelligence basically in the workforce basically to accelerate learning and development, to help diagnosis, all sorts of different things. Sort out government regulation, that's a conversation we were having earlier. We can use digital twins basically of water factories and utility plants basically to actually analyze and optimize basically water utilities. But we also have augmented reality. So increasingly, if we have a look at the aviation sector, you go up to a Boeing aircraft, you don't pull up a manual any longer. You use artificial intelligence to diagnose the problem using predictive maintenance, and then augmented reality simply tells you exactly what to switch out with what. So when we actually think about how we apply some of these newer technologies basically to what is a millennia-old industry and trade, there's lots of opportunities. As I was with my daughter earlier, basically we're sort of travelling through Solihull, and there are plumbing shops. Now, as an entrepreneur, basically the plumbing industry basically is worth $9 billion. Today, I can use artificial intelligence in about 10 minutes, have a website built. I can have an e-commerce site built. I can analyze all of you. I can understand the competitive dynamics across the UK, basically, of the entire industry. And then as an entrepreneur, I can start picking my battles. A £9 billion industry is quite interesting from an entrepreneurial perspective. We also are increasingly returning back to nature. So when we think about filtering out all of the junk, basically, from our rivers, we're using reed beds, we're using different plants, different biomes and biospheres. And then when we think about a circular, shall we say, water economy, bearing in mind that water is already its own water cycle. In Singapore, at the moment, basically, they reclaim and recycle and reuse 40% of all consumer water. They want that to be 60% by 2050. In Israel basically currently recycle and reuse 90% of all of their water. In California, they're trying to get to 30%. So do we have solutions basically to water scarcity? Bearing in mind that at a very fundamental level, when you have a look at the Aztecs, when you have a look at the Mayans, those civilizations collapsed. Not because AI Terminator robots basically went through the Mayan temples. Those civilizations collapsed because the water courses that they relied on, the rivers they relied on, either dried up or changed. The fact of the matter is, without water, there is no life on this planet. And without, just look at Mars. And without water, there is no civilization. So ultimately, from an industry and trade perspective, when you're actually helping someone with their plumbing, you're enforcing a United Nations human right. You are making sure that the right water gets to the right place at the right time. And you are fundamentally helping people survive and live and thrive in whatever area they are actually in. That's all you're doing. So as an industry, there's a huge amount of opportunity ahead of you. A technological opportunity. When we have a look at training, it's encouraging to see so many new people coming into the workforce. But don't stand still. And that's it from me. So thank you for listening. I hope you enjoyed that. And it's lovely talking with you.
Thank you. I'm very keen, Matthew, for you to stay on the stage.
Yeah.
And I know from experience now with this group that we have quite an inquisitive group. And I think we have somewhere a roving mic as well.
Yeah.
And he runs like a gazelle. He's very fast.
That'd be one to see.
I've also learnt that. Can I open this up and see if we've got any questions from the audience? Great, we've got one. I've got one just in the middle. If you could just give your name, that would really be great.
I'm Henry Hung from Hong Kong. One thing it's not a question, but it's something I would like to share with you that not many people paying attention to. You mentioned about the flushing water for the toilet, right? So we use about 2 gallons or 2.5 gallons for one flushing. But have you thinking about the water that we don't need to treat it? In Hong Kong, we use seawater for flushing. I don't know how many people have been to Hong Kong. When you flush the toilet, you don't know whether it is fresh water or seawater. I think that only in Hong Kong around the world using seawater. So I would like to say other countries will imitate like Hong Kong using seawater for flushing. Thank you.
See, I must admit, I didn't know that because I've never tasted the toilet water. That's it. So, however, a lot of the dogs probably would. But no, in all seriousness, I mean, it's things like that, you know, where you're diverting, for example, fresh water and actually redirecting that to salt water, you know, albeit then sort of processing and everything else. You know, that's another very intelligent use, and I didn't know that. And I work with the Hong Kong Trade Development Council. That's it. So now I'm going to, and the Hong Kong University. So I'm going to mention that to them, see if they know. That's it. But again, it's a different kind of thinking, isn't it? You know, why aren't we using grey water or brown water to flush toilets, for example? And so, you know, some new builds we think about it, but certainly not salt water.
No, I'm curious about how you treat it, but I'm not allowed to ask the audience questions, I don't think. There's a question down here in the middle.
Thank you very much. I was absolutely fascinated by your very fleeting reference, and I'd love to know how it works, to the closed-loop AI data center in Austin, I think you said.
Yeah, in Texas, Austin.
How does that work? And are there plans, for example, for all the water-guzzling ones to convert to that?
Yeah. So the way it works basically is essentially this hyperscale data center has got 2,000 GPUs. So you can essentially just like a regular data center, just huge numbers of racks. What we've done basically is we use liquid cooling. So we use liquid cooling to cool the GPUs and computer systems and everything else, but it's all closed loop. That's it. So from companies like Xylem and these sorts of things, it's perfectly closed loop. You never need to bring water in from the outside. So You push water over the actual servers. So ironically, if you put an actual computer server into water, it sounds counterintuitive because it's electrical equipment, and any plumber basically and any electrician knows basically that the two should never meet. But you can actually submerge computing equipment, most computing equipment, in liquid cooling systems, and it's highly efficient. So all you're doing is then you have a radiator. So you're taking heat out of the data center racks, and then you're cooling it. So you have a lot of external cooling into the Earth's atmosphere. So that's kind of the next problem to solve, or you can push that into the ground, but it's closed loop. Now, from a data center perspective, we've seen the second is planned for New York, but Google's first waterless data center was the first, and it's the only operational one at the moment, because this is sort of about 4 months old now. But from a cooling perspective, they've been trying, so for example in China, as well as the United States, also trying to cool data centers actually down at the bottom of the sea. And then we've got other data centers basically in Finland, Sweden, Norway, Iceland, etc. from a cooling perspective. But the closed loop water cooling system that Google have actually developed, that looks like that will be pushed out basically to other data centers. So AI data centers, when it comes to electricity use, cooling, and everything else, there's stories there, but we have a couple of solutions on the truck now, and they are operational.
Fascinating. So are they more expensive?
They are. They increase the capital expenditure by about 2%, which on data center is large. However, when you have a look at the ROI, it reduces the ROI because you don't need as much water treatment. You don't need to bring water in.
So it's cheaper to operate.
Yeah, from a community perspective, a lot of communities are saying we don't want a data center in our backyard because, they're gigantic buildings. We don't like the look of them. They're using huge amounts of electricity and they're putting our prices up. And they're siphoning off huge amounts of water from local communities. So companies like Google are sort of taking all of those and going, how do we make all of those problems go away, except for the actual look of the data center? And they sort of go, well, that's what it looks like. We'll put some trees up.
Excellent. Well, I'll...
No, sorry.
Yeah, let's have a quick follow-up question. Go for it. Here comes the mic.
Oh, sorry. One discussion I've had with somebody was, okay, you need a lot of cooling. Where's the coolest place on Earth? Well, it isn't in Earth, it's in space.
Yeah.
So I hate to say that the person who controls most of the satellites up there is a certain person I detest.
Mr. Musk.
Yes, I hardly dare say his name. So I'm crossing that. However, is that I mean, you're a futurist.
Yeah.
Is that something that could potentially be developed? Could they be put up in space?
So the quick answer is yes. A little bit more of a detailed answer is the current SpaceX Falcon Heavy, which is the big rocket, basically when that actually successfully launches, and when it's usable, that will take the cost of launching a kilogram of stuff into space down to $30. Bearing in mind that it used to be $10,000 per kilo. So, firstly, you've got a very low-cost launch vehicle that can take 250 tons into space. The biggest issue with assembling data centers in space is you need to, frankly, launch a huge amount of stuff. When you have a look at a hyperscale data center in space, you'd need something like 1,000 launches. Now, from an economic perspective, if you have a 1 gigawatt AI data center on Earth, then companies like Meta, Google, Nvidia, etc., Microsoft, will spend about $30 billion building that data center out. We estimate that a gigawatt of data centers in space would cost about $1 billion with the new launch dynamics. From a radiative cooling perspective, you use something called near-infrared radiative cooling. So you have computer chips generating a huge amount of heat, and they just radiate it into space. But you need solar panels and you need computing gear that radiates heat differently to the systems that we use on Earth. So we need to re-engineer them a little bit. So it is feasible to put them up there. The second problem that we actually have is you need to use what we call free space optics to connect the data centers together in orbit. So that's essentially using laser links basically to transfer data between the different data centers. But then you also need a laser link down to Earth, because if you imagine, so for example, we're generating about a zettabytes worth of information just on health per year. And it's all very well having a giant data center in space, but if you can't get information to and from it quickly with low latency, it's just floating around useless. So data centers in space, yes, you need a huge amount of launch capacity, but it can work, but then it relies on the amount of data upload and downlink that you can actually provide. And that's what we're working on in Singapore, the UK, and the US and Japan.
So people working on it. Thank you for that question.
But it's also a long-term thing. This isn't happening now. I'm going to put that in there because Elon Musk basically keeps saying it's now. It's like
one from David, and then we've got maybe time for one more question.
Back on Earth,
the
human right, meaning clean water and sanitation, isn't met for 3 billion people approximately, roughly a third of the world's population. How are you as a futurist helping governments and businesses drive the haves and the have-nots here? Because it just doesn't seem to change, and we still have millions who aren't able to access clean water.
Yeah, no, it's a great question. So when it comes to being able to provide people with clean water at a very local level, at a dwelling level, we can extract water from the Earth's atmosphere. We can do that with using a variety of different technologies, but you need the capital to buy these things. So on the one hand, you've got the capital problem. When we talk about building out infrastructure, so this year we're spending about $3 trillion building out infrastructure in terms of water, so water, utilities, electricity systems and everything else. The biggest issue that the vast majority of people around the planet actually have are 2 billion people roughly take part in the informal economy. If you want to provide water basically to a slum in Soweto, basically, or out of Delhi or whatever it happens to be, the fact is basically that you need piping. You need distribution and water treatment centers, and we're building those, but they're highly capital intensive. And at the moment, you've got relatively high global interest rates, high inflation. The return on investment for investors basically isn't particularly there. So what we're seeing the Chinese government especially providing a huge amount of 0% financing to sort of bricks and road initiatives. So on the one hand, you've got the problem of 3 billion people without access to clean water. We need water treatment plants, desalination plants, pipes, infrastructure and everything else, and then the people to actually build it and do it. At a local level, we can provide things, so we're doing that sort of throughout Africa to a different degree. But then on top of that, a lot of the companies that want to build build the water infrastructure, they charge a lot of money and they don't transfer the IP. So at the World Health Organization, basically we talk about, developed nations actually doing technology transfers so that local indigenous populations can actually build things cheaper. And frankly, basically, if you're a gigantic organization, why do you want to give your valuable IP away for free? So again, that's sort of where I sort of said earlier, we have solutions to all of these different things, but the reason basically why we still have a lot of these problems is because of either investment or will. Every year we're spending $2.1 trillion now on weapons and armaments. I've always postulated, while the world will always want to buy military arms and stuff, what happens basically when you start diverting $500 billion of arms and weapons purchases to, say, providing drinking water? You'd move the dial. You'd end up with corruption and bits and bobs, but you move the dial. So the reason why we have 3 billion people on the planet basically who don't have access to safe drinking water isn't because we can't do it. It's because who's paying for it and who will do it. Oh yeah, it is. And it's, but this is, a lot of the global challenge comes down to the fact that the weather is changing. I mean, we've seen that today. I mean, tomorrow might be the hottest day in the UK ever at 40.3 degrees Celsius. So the weather is changing, and this is kind of the other problem. When we have a look at California with the droughts, Lake Mead got so low, basically, that California was 1 meter's worth of water away from not being able to generate 50% of its electricity. So you've got these compounding issues. But do we have a solution? Could I provide clean water to 100 million people? Yes, give me the money, I'll figure out how to do that. Just write me a check.
So we're just going to come to our final question. Oh wait. I think
we can do some quick fires.
We'll do some quick fires. It has to be.
Fires.
So Matthew, I'm timing you.
Right.
Hi.
Quick question, and we'll get Marla.
Just a quick one. There are, as you said, technologies, little stepping stones that we can all approach and do, like the data centres. If you have a water-rich data centre, why don't you put near agriculture that you can then feed the agriculture side, which is then a double use for the single source? Or like we have condensate from fan coil units. Why are we not using that more effectively? I know it's a contaminated water, but it's good enough for flushing.
Oh yeah.
Okay.
Well, absolutely. But this is sort of where when you actually cohabit. So another example, for example, is we take from the energy industry. We take the waste heat basically from the data centers, and we pipe them to local community swimming pools to heat the swimming pools. That's it. So when you have a look at dual use, absolutely. But that just requires people to sort of go, why don't we do that and put that together? And people go, why? And you go, well, because of this. And here's the business case. And this one goes, that sounds a good idea. And they do it, and off we go. But yeah.
Some good positive ideas, solutions. And I think Marla.
Yeah, well, thank you very much for a very stimulating talk. My question actually, extends from what David was asking you.
Yeah.
92% of the carbon carrying capacity of the atmosphere has been used up by the global north. And all of the problems, literally all of the problems, are in the global south. And, you ask us to be optimistic, and against that background, even AMOC, the Atlantic Meridional Oscillation, is now regarded as almost certain to collapse if we carry on going the way we are. And runaway climate change is also very much on the cards. So with that background, do you actually believe that the global north is going to give the global south what it needs in order to allow survivability of all of us on the planet? So my question, given your optimism and your future thinking, is just yes or no? And that's
yes.
So, that's fine. No, I do not think the global north is going to give the global south what it needs. However, when we have a look at climate change, European and Chinese CO2 emissions are now dropping. But realistically, so I do a lot of work in the global south, so Latin America, Africa. There's a huge amount of innovation basically throughout all of those different continents, but frankly, are they getting what they need when they need it? Are they getting the help? No. They are getting talk, and they are getting limited assistance. So my answer is no.
And I'm so sorry, because I know we've got more questions in the audience, but unfortunately we've run out of time, and I'm hungry. Oh, that's terrible to say. But this has been a really enlightening talk, and thanks so much for your engagement as well. I'm now have the pleasure of thanking Matthew, and if you will join with me in thanking Matthew for that wonderful speech.
Thank you.
We have Sandra has got a small gift for you as well.
Just some nibbles.
Is it a bottle? Is it liquid?
No.
Some tap water.
That's it. It's a new Quooker tap.
No, don't start me on that.
Oh, no.
Excellent. Brilliant.
Dear. Right, thank you everyone.
Thank you, Matthew.
Thank you.
So, we've just got, before we close, we have some really special guests. So I think Sandra alluded to the fact that one of the things that we like to do at the Worshipful Company and Plumber, and one of the things that we really need, is to be better at recognition and thinking about role models that we may well have, especially for people in their early careers. And at the Worshipful Company of Plumbers, and I know the World Plumbing Council is the same, we want to take time to recognise excellence in plumbing. So we've got some wonderful examples of talented plumbing starting in their career. So, for example, I'm delighted that each year the Worshipful Company of Plumbers is able to recognise bursary winners. We award 6 bursary winners every year to help people out at their start of their career. And I'm delighted that we have some of those bursary winners with us today. We award them to students who we believe are showing absolute dedication to the trade, and we know that the bursary for them would make a really meaningful impact for them there on each of their careers. And they're all strongly supported by their colleagues and their employers, reflecting both their commitment and talent and the potential. So I now invite the master to present some certificates, which I'll grab. And if I can ask you to give a warm welcome to Jack Payne, Jessica Black, Alice King, and Jack Winstone. I'm not sure, we may just have one or two. Jack's certainly here in the audience. It's Jack, isn't it? There we go. Brilliant.
Jack, many congratulations. That's absolutely wonderful.
Is
if
it
you look there,
Alice?
I think you'll find people are taking your photo.
Excellent.
That's
Great.
it, perfect. Wonderful.
Well done, Jack. Great, and here we have Jessica Black.
Jessica, so glad to see a woman up on the stage. Wonderful. Can I present you with that? And you go that way and look that way. There'll be various people. Wonderful. Very well done.
The company also supports the World Skills Competition and certainly the UK entries to Plum Skill. Can I just check if we've got Jackson Gill and Jack Fenton in the audience? Excellent, brilliant, that's good. I just wanted to call out and you not to appear, that would have been fun. So, as we've heard before, we had that great video yesterday. The annual skills competition is designed to promote standards and skills for plumbers developing competence into excellence. So each year, talented young plumbers test their expertise, and actually I know there's been some great work done today in the installer show hall as well. So I'm now going to invite both Jackson Gill and Jack Fenton to join us. They've been both winners in the Skill Plum UK, and we're delighted to give them awards for excellence as well. If they'd like to come up, that would be super.
Very well done. There we go.
There you go.
There we go.
If you'd like to come up together and get your picture together, that would be super.
Right, you'll have to tell me which one's which. That's Jack, and you must be Jackson then by a process of elimination. There we go. Dylan's, it's Dylan.
We've got one extra.
Dylan, you're coming up too.
Oh, it's Dylan here! Oh!
Well done.
Well done, Dylan.
Perfect,
Sorry, Dylan.
Dylan.
I didn't realise you were in the room as
I'll
well,
tell
but
you
we were
what,
ready for you.
Shall we move along a bit? It might be easier. There we go. Come on, all of you. That's it. We get you all in. There we go.
Sorry.
There we go. One more. I'm going to come in the middle of you if you don't mind, because I'm only little. Wonderful. Thank you very much. Very well
Great.
done, all of you.
I'm delighted to announce that Jack Winston, one of our bursary winners, is here as well. Jack, would you like to come up too? Excellent. Well done, Jack.
Oh, you're going the long way. That's it. Perfect. Oh, well done. There we go. Can I shake your hand first? And then we'll do that one. It's doing the smile. Okay. We done? Perfect. Very well done.
Very well. It's interesting. We've had, that was almost a slightly concerning speech. We've got some really amazing challenges in terms of water scarcity. When I see talented young plumbers coming onto the stage, I get cause for optimism. I've got probably one of my favourite awards now as well. So for our final award, we'd like to recognise someone who's been selected to represent the UK in the international competition of world skills in Shanghai. I know we've got other students going to Shanghai that are with us today as well. We think this is an amazing achievement, not only with the talent to succeed in plum skill, but also to demonstrate a huge dedication to train, and I know how hard they train to hone their skills for world skills even further. Every year we give one gold medal to someone who we think really deserves it within the company. So the Worshipful Company of Plumbers Gold Medal Award this year goes to Andrew McCann, our gold medal winner. Here he is.
Stay with me, we do this one together.
Yeah.
I've got two.
We've got one's the
There we
certificate
go.
persons.
Very well done.
And that's your gold medal.
That's your gold medal. And it's the three of us. Well done.
Well
Really
done.
good.
Congratulations.
Very well done. That was
Did you get
brilliant.
this for the winning of the prize? Well done. Excellent.